Okay, we should be live. Let me get a
All right.
tweet out here.
We verify. It's out. Twitch.com.
Yeah, all right. It's
There we go. I see me on a
mute
slight delay.
myself here. I know I'm totally getting the echo here. Okay.
That's okay.
And how do I let's see, present. Let me get on Replit here. So how do you want to do this? Do you want to use Chatbot UI? Do you want to do a custom
Yeah, let's do the
implementation?
custom. That Vercel one looked cool. So
It's very easy to get because we're handling the back end stuff, right?
yeah, so I thought we were doing it a couple ways, right? So you can basically do it server side, right? But like the problem with doing it server side is you don't have the commitments. But so if it's just like for a request, then that's normally fine. But if the request has a special body to it, right? Like for example, if you're doing chats, then the thing that you want to make sure is not happening is that like I hit the endpoint and I say, hey, I've got a 2-sentence prompt, right? You give me back the invoice for that. I swap I pay the invoice, but then I swap out the body, and then I say, hey, I paid the invoice. Here's my like 20,000 token prompt.
Yeah.
Right. And so for that, you have to do server side validation where you have to send a token back that commits to the original body. Right. But there's like a couple steps we could go down. Right. So we could just do like super simple client side lightning payments just using WebLN. And then after that, we can use the L402 error code. Right. So, yeah. Let's do it that way.
Okay, let me tweet out this link.
Yep.
What do you want me to? What's the best?
You just do like going live to make a lightning powered chatbot. With at Cody Lowe.
Implementing. Let's see, what is Vercel Technicals? AI. Let's tag Replit. Why not?
Yeah.
Okay, this is probably good. Okay. Boom. All right. I guess probably just create a new REPL here and.
Yeah, you want to share your screen first, and then hopefully we get some people to jump on. But for like the posterity, as this, we get the long tail of viewers for a couple dozen years after this, is like the first time that McKay Wrigley learned how to do lightning payments. Do you want to give a quick intro, and then let me actually start, because like you were the guy who first got me onto the idea of using lightning payments for chatbots, and the reason why was because you were the first guy to like start publicizing chatbots of like outside of OpenAI. Here's how you could do this. But the way that you did it with Chatbot UI was like bring your own API key, right? And like, you want to go into the reasoning behind that of like,
yeah. So the reason I originally built it was there were a few reasons. So for one, I wanted a few extra features, primarily folders and a prompt template system.
Mhm.
So I spun those up, and then I was like, well, I might as well just open source this UI because it's turned into the thing that I use all the time. And then obviously it got kind of popular because it was sort of the first template that kind of got popular, just by pure chance. And it turned out like the bring your own key thing worked pretty well. And because like another thing people forget, and this still applies to GPT or Chat GPT, is like even if you're a pro subscriber, your GPT-4 usage is still metered to 25 messages. So it's like if you want to get beyond that, you need some sort of user interface to allow you to do that. So that's kind of the Fuller thing, the prompt system, and then unlimited GPT-4 usage were sort of the core reasons I implemented the original UI for that.
Yeah, but for when you publicly deploy it, right? Like you can't put your own API key in there and just be like, yo, everybody use my API key. Enjoy yourself.
Right. So I did this. I actually did this the other day or last week with the stream I did where I decided to try it out. And sure enough, it's like you start running into like rate limit issue. Because the second you tweet it out, assuming you like, if you're a company, for example, and your distribution's good or something, and you have a lot of followers, suddenly everybody jumps in at once.
Yeah.
And then it turns into this like terrible experience where everyone's like competing for your API credits. If you go over the usage limits, you have to, it's just a whole mess, right? Like I had basically a Stripe link. I was like trying to beg for donations just to see how it would work. And like, sure enough, like a few people donated, but it's like, it's sparse and it's not tied to the requests, which is where.
Well, I think that's the easiest client side one. So you actually want to do that first, and then we can go to the server side way of doing it with like the actual chatbot, because like the server side way is doing it better. But just like it takes like 5 lines of code to make that donate link that you put for your It takes like 5 lines of code to make that a client side Lightning invoice if you want to see that. So do you want to share your screen? Maybe we could do that first and then go on to the chatbot.
Yeah, I think that sounds good. So for context, for anyone who watches this now or later, I have never worked with Lightning payments before. So this is going to be a fun thing. So let me come in here and share my screen.
Mm-hmm.
Let's see, present, share screen. Let's do.
He can come in.
Entire screen. Okay. Here's my desktop. Should be able to drag this in. And for context, we're going to be using Vercel's AI chatbot template.
Yep.
Which is a very, very good template. If anyone was starting from scratch, I highly recommend this template. It's very well done. Vercel obviously does a lot of great work.
Mm-hmm.
And we're just in here. We're on Replit, of course. And we are basically, I just cloned this repo into a REPL. And we're just going to start from here.
Yeah. Cool. So you're going to hit run? Or...
We just set up all the fun build stuff. Okay. I'm trying to think. Is cloning even the best way to get this started?
It should be. So I think you might have to do npm install first, or next not found. That's normally a bad sign. Let's do. Yeah, you gotta do npm I first, and then once that's there, then that should get you the next command. And then can you invite me to this REPL?
Yes.
All right, what do we got there? While resolving, could not resolve dependency. Fix the upstream dependency. Just I do force. Yeah, it's just Cody. Cool. Sweet. So there we go. And so while this is installing, first thing we're going to do is we need to get you a Lightning address, right? And so the easiest way to do that is just with Alby, which is like they run the node for you, right?
Okay.
But afterward, we can connect that directly to one like your Lightning node. But for right now, let's just like set it up just to get it running. So if you go to getalby.com.
Am I spelling this right?
ALBY.
BY.
Not default site.
Yeah.
There you go. And
Okay.
browser extension. So this is just going to be, this is like a Lightning wallet that's embedded into your browser, right? And it's going to create a window.webln object. And so that's the way that you're going to interact with it, right? And so like the keys stay segregated in the browser away, in the browser extension away from the rest of the browser, right? So,
all right, I'm just choosing my password here.
Yep.
And let me create a new Albi account. Yeah.
Yep. So if you want to move that back, so there's two ways to do it, right? So Albi offers that they'll like run a hosted version for you, or you can connect to your own node, right? And so just to like get it up and running and kind of get moving on these things, we're going to set that one up first. But then afterward, we can set up a voltage node, which is like your own node where you control the keys for it. And we can connect that to your Albi, right? So.
In here.
Cool.
Okay, so we are in Albi.
Yep. And so Albi is a browser extension. So if you go up to your extensions tab now, and then the one on the left of that, there you go. And then in Albi, you click there. There you go. And so what we can first do is we can set up a Lightning address for you, which is mckayWrigley@getalbi.com, right? And so I can just send directly to that one at getalbi.com. I'll send you that. Let's see, 10,000 sats.
Remind me, as one sat is a millionth of a Bitcoin?
One sat is 1/100 millionth of a Bitcoin.
1/100 millionth. Okay.
Yeah.
I got my denominations wrong here.
Yep. Okay. So if you hit refresh real fast, you should have received a couple thousand sats. There you go. Boom.
Boom.
Okay. So that I hit from my node, right? And
can we pause for 2 seconds and recognize how cool that is? That just permissionless value has been sent. We didn't need to go through a third party.
Yeah, well, I mean, you're
very cool.
Third party on this one, right?
Yeah,
he's hosting your node for this, right?
Yeah,
but
sure.
Once we move over to a hosted, to your node through Voltage, right? Then we can connect Albi to that, and then Albi doesn't have the keys, it doesn't have any of the material, it can't spend anything. All it is just an interaction layer with that node, right?
Yeah.
And so, cool. So for this one, let's first go over how the Lightning address specification works, right? And so the Lightning address specification, if you want to look this up, or I can get the link for you for this while I explain this, right? So Lightning address, so the Lightning address is like a URL way of an HTTP way of interacting with Lightning nodes, right? And so sometimes you don't want to have to communicate directly with the node. You want to do it over HTTP against a server just because it's like a lot easier, right? And so where do we go? LNURL pay. LNURL pay. Lightning address, Andre Neves. Cool. So let me just send this to you real fast. I sent it in StreamYard. So the Lightning address is something that works really, really, really well. So if we scroll down if you scroll all the way down for there, that graphic, this is the way the Lightning address works, right? And so you're mckayWrigley@getalbi.com. And so when my wallet sees that, it's going to hit against getalbi.com/.wellknown/LNURLP, which is Lightning URL Payment Protocol /MckayWrigley. And then it expects to get that JSON back, right? So let's just in your browser real fast, just like open up a new browser tab, or you can do a curl or something, but just do https getalbi.com /.well-known /LNURLP URLP Lightning URL Payment Protocol, right? So LNURLP. So there's an N. Yeah.
Boom.
/MckayWrigley.
Okay. Can hit this.
Sweet. Okay, and then so you get this response, right? And so what is this telling
Okay.
you? This is like the metadata associated with your Lightning address, right? And so
Interesting. Okay.
this is that the minimum sendable is 1,000 millisatoshis. So the minimum that I can send to you is 1 satoshi, right? So
Mhm.
millisatoshi is 1/1000th of a satoshi.
Okay.
A satoshi is 1/100 millionth of a Bitcoin, right? Max sendable is, I think that's it's probably like 0.1 Bitcoin or something, right?
Yeah.
And then you've got like a Nostr pub key that's auto generated for you down there. We can talk about Nostr later if you want. Nostr's fun. It's an open social network protocol. But and then it's got a callback, right? And so that callback is the thing. So was the first verification of like, does this Lightning address work, right? And then it tells you, hey, hit this callback if you want to get an invoice,
Okay.
right? And so if you send a GET request against that, so just click on that link. Notice that you get invalid amount, right? So the invoicing system for LNURL requires an amount associated with it. So you have to pass that as a query parameter, right? The reason why is because when you don't want to just like hit someone and be like, oh, like I hit you and I say like, oh, I want to use your GPT-4, and then you come back with an amountless invoice and just be like, pay something, right?
Mhm.
Like you want to have the amount tied to the thing that they're asking for. So you have to send an amount associated with this. So at the end of that callback right there, if you can do question mark amount equals like something over 1,000. There you go. Cool. So that's for 1 Satoshi and 1 millisatoshi, right? So if you go look at that, you've got the status okay, right? So like that worked. Success action is that there's a message that's going to be like, hey, thanks, sats received. And then the PR down there, that's a payment request. And that's what a Lightning invoice looks like, right? So
Okay.
normally you send to, well, if you're using on-chain Bitcoin, you use a Bitcoin address, right? And so that's just me telling the entire world, hey, I'm unlocking Bitcoin and locking it to this new thing, which in a human readable format is encoded as an address.
Okay.
Right? For this one, we're using the Lightning Network. And so we're just communicating peer-to-peer. This is the node that I'm talking to is telling me, you have to satisfy the spending conditions. You have to show me that you paid this invoice. And if you show me that you paid the invoice, right, then we can do things. And so if you go to that invoice, if you just copy paste that, go to the invoice, copy the whole thing, the LNBC one. Sorry, that's the verify URL. But actually, let's go there first, right? So verify is just a way, like we said, of going client side, right?
Yeah.
See where it says settled false, pre-image null?
Yes.
So that invoice has not been paid yet, right? And so on the client side, if you wanted to have like a loading screen of like awaiting a payment, you can have this hold against that verify URL until it says settled true and the pre-image is there, and you can verify that the pre-image matches the spending condition of the invoice, right?
Gotcha.
So now let's take that invoice real fast. And
that's just this address, yeah?
Yeah, it's an invoice, not
this
an
is
address.
an invoice. Okay.
Right?
What's the difference between those two?
So the address, right, is a human readable encoding of a Bitcoin spending condition, right?
Okay.
And so normally the Bitcoin spending condition is like, so the way that, if you want to go to real fast, just to blockchain. Yep. So let's go look at the blockchain. Just go to mempool.space.com. Sorry, mempool.space, no .com, my bad. So this is like a block explorer, right? And so we can go look at this of like what's going on the Bitcoin main chain. If you scroll up and click one of the blocks that has already been confirmed on the right-hand side. So we're at block 797526 and scroll down, right? So this is like the Bitcoin blockchain, and the block contains transactions. The transactions have inputs and outputs. If you see those inputs, how they're saying like, hey, it's from this address and locking to these different addresses.
Yes.
Addresses are just human readable encodings, right? The thing that it's actually doing is it's unlocking some Bitcoin and it's locking it to different spending conditions, right?
Gotcha.
And so the thing that makes it so you own Bitcoin on the base layer is I can prove to you that I know how to spend it, right? Because the only person who would know the spending conditions, like the things that would satisfy the spending conditions, is the person who generated the lock.
Okay.
Right? So like, let's go click on one of those transactions real fast. If you click on the transaction ID and then go to details on the right-hand side. Details. Boom. Okay, cool. So what do we see on the right-hand side, right? We see script pub key. And the reason that's called it's also called the the locking script. And the reason why it's called a script pub key is because originally with Bitcoin, you would lock Bitcoin to a public key, right? And so that's what an address is. An address is, you can think about it as, so this is just like somebody's public key, and I'm locking the Bitcoin to that one. So McKay has a public key, and Cody is telling the rest of the world, hey, I'm unlocking some of my Bitcoin, and I'm locking it to this public key. And everyone else in the world can see me do that. So on the base layer, you have very bad privacy. And the reason why is because I'm telling the whole world, hey, I'm locking it to this thing, and they're verifying and seeing that I did that, right? And then for you to unlock it, if you go look on the left-hand side over there, right? So that thing has two things associated with it. On the bottom of that witness stack, the thing that starts with the 03, that's a public key, right? And so what that is the address that you're spending that out of is called a pay to public key hash. So the thing you locked it to was a hash of a public key. And so you're saying, this is the public key. So I know the public key that when hashed equals this hash thing. So that's part of the spending condition. And the other part of the spending condition is I can generate a signature associated with that public key. And so the thing on top of that is a signature. Does that make sense?
Yeah. So where does Lightning fit in to this?
So here's where we go into this. Okay. So if you go to if you scroll up and go look at if you go hit the Lightning button there, it's a Lightning.
Literally Lightning. Okay.
Yeah. So that's a visualization of the Lightning network, right?
Very cool.
So the thing that you're doing to open a Lightning channel is that, remember those spending conditions that we talked about? Of that, like I'm locking Bitcoin to a spending condition. Well, the thing that I'm locking it to is a 2 of 2 multi-sig between two channel parties. So me and another node, right? And I'm saying, hey, the only way that you can spend this is if you get signatures from both parts of the nodes, but both parties of the nodes. And so me and the channel partner, what we're doing on the Lightning Network is we're privately updating the transaction that we would broadcast in order to close the channel, right? So this is why Lightning is so fast relative to Bitcoin. For Bitcoin, you have to wait for the block to get included. For Lightning, I'm just talking to my channel partner. Does that make sense?
Yes. So what's unclear to me, how does this leverage sort of the security of Bitcoin's proof of work system so that this works? Securely?
Yeah. So what you're doing, right, is that the way a Lightning transaction works is that I open the channel with you, right? And then you're holding one version of the transaction and I'm holding a different version of the transaction. Now, both of those say that McKay gets 100% and Cody gets 0% if you're the one that opens the channel, right? Then you sling a payment to me. We both update our transactions that we're holding. And now it's Cody has 50% and McKay has 50%, right? But the one that I'm holding, if I broadcast my transaction, you get your money back immediately, and I can't get my money in for like 2 weeks. It's called a lock time contract, lock time spending condition, right? And so during that 2-week period, it's locked to a special address where you can publish a proof that I tried to steal from you. And if you publish that proof, then you can sweep it out of that address during those 2 weeks. But I can't do anything about it, right? So that's the security of it, is that you can always broadcast your transaction onto the main chain in order to close the channel with your counterparty. But as long as you don't do that, then you can sling payments back and forth as fast as you want, and you're only communicating between each other, not the whole world like you are with Bitcoin. Does that make sense?
And so each node needs to grab the updated state of the base chain in order to, I guess that's what's unclear to me, is how does each node ensure that the state between all of them is consistent?
So the only consistent state that they have between all of them is the Bitcoin blockchain. The state that they have with each other's channel parties is just their channels. And then there's you can have gossip about the wider Lightning Network, because if I want to pay McKay, but I don't have a channel directly with you, I can pay John, who pays Dave, who pays McKay, and we can make that an atomic payment where it only goes through if McKay ends up getting paid, right? That's why it's a network. But the only global state that we have to all agree on is the Bitcoin blockchain.
And so each one of these transactions on Lightning are getting recorded to Bitcoin?
No.
Or is that's done through the proof?
This is why we go to the invoices, right? Because the invoices, all we're doing is updating the transaction, right? So I'm you have a transaction. I'm holding on to a transaction if I'm a channel party with you. that says I have 50,000 sats and you have 50,000 sats. And then you and me update our transactions. And now we have one that says I have 49,999 sats and you have 50,001 sats. And so what we just did there is we just updated those. And so if I publish an old transaction, I'm locked for 2 weeks. You publish the proof. You sweep all of the money back to yourself, right? But if I publish the most recent one, well, I didn't cheat there. And so I just have to wait 2 weeks, right? Or we can negotiate a cooperative close. And a cooperative close, we just both get our money immediately. Like we both just go our separate ways, right? But so like the payment that I just did with you was my node making a route from me to Albie, who's hosting your Lightning address. And then it just slings the payment. And now all of the nodes along that route that I did, which could have been 2 hops, 3 hops, 5 hops, whatever it is, they updated their private transactions that they're holding with their channel parties. Right?
And so this LN URL, this is running on Albie's node.
Yeah. So Albie is running a node and they have a Lightning address server. And like they're doing the internal accounting of that. It's like, this is McKay's, this is not, this is whoever's, right? And so the way that we'd first set it up was just like doing that one. We can set up your own node and connect it to that, like to Albie locally, right? And then you're just like running it on your own stack, and it's just like a way to interact with it that way. But this was just like a fast setup that we did.
Right. And what's the advantage for me to run my own node compared to using? Because like, so for me, using Albie is super convenient here because I don't have to do anything on my end to run a node. So is it just not having to rely on a third party? Is that
that's exactly the reason, right? Is that like, if Albie decides to turn their nodes off and stop replying to your HTTP requests, right? Then like that's your money gone, right? Okay. But so if you sweep it to your node, then you can decide when you want to like sweep it off of Lightning onto main chain, or if you want to put it into whatever you want, right? Is that like, you get to be the one that decides what you do with your money, and no one can stop you, right? For this one, so relying on Albie. To send Bitcoin on Lightning, does that mean you have to deposit it to Lightning first? And then, so you have to. So you can do a zero confirmation channel, right? Which is basically you just publish the transaction. It's in the mempool. It hasn't been confirmed yet, but you can start operating with it off of
And the mempool, sorry to jump in. That's just the transaction pool, correct?
Yep. So if you go to
Lightning, unconfirmed transactions,
if you go back to the mempool.space,
yes.
Right? Cool. Yeah. So the right-hand side is like the Bitcoin blockchain. The left-hand side up there are all the transactions waiting to be confirmed in blocks.
Okay.
Does that make sense?
Yes. So this is a block. These are confirmed blocks, and then
those are forecasted next blocks, right? So based off of the transaction fees, because miners are incentivized to get the highest fee transactions. So mempool estimates that based off of the different fees, this is how I would construct the block if I were trying to maximize my returns.
Gotcha. Could you do a 60-second Bitcoin block TLDR?
Yeah, sure. So if you go to click on one of the confirm blocks real fast.
Yep.
Right. Cool. So if we look at that, then we do scroll to the top, please.
Top.
Right. So that's the block header. That's the metadata associated with that block. Right. And so if you look at the hash for that real fast. So if you see that hash, I think you can hover over it. Yeah. And you see on the bottom left, see how it's like got a lead of a bunch of zeros.
Yes.
Right. Is that what they're doing is they're hashing the metadata of that block. It's called the block header. Right. And so the block header contains a bunch of stuff. Like one of the things that it has is a Merkle root, which is a commitment to all those transactions inside the block.
Gotcha.
Right. And so what they're doing is they're hashing, and they're trying to find a way that they can hash it such that it satisfies the difficulty requirements. And the difficulty requirement is it needs to be below a certain number. Right. And so you can see all those leading zeros, right?
Yes.
It's a very, very small number relative to the possible search space of SHA-256, which is 2 to the 256, which is more than the number of atoms in the known universe, right?
Yes.
And so that's like what that hash is. You see the timestamp there?
Yep.
The timestamp is another critical part of the block, right? Is that the critical thing that Satoshi solved was the double spend problem. The double spend problem is if I send a transaction to McKay and the same transaction spending the same coins to my wife, I need a dispute resolution mechanism between those, right? So fundamentally, what Bitcoin blockchain does is it creates an order of time. This transaction happened before this transaction. You always have a dispute resolution mechanism. So I can try to cheat. I can broadcast the transaction 100,000 times, right? All of those just sit in the mempool. Miners select whichever one pays the most, and then they confirm that one. Once it's confirmed, well, now everyone in the world can see this Bitcoin has been spent. And so if I try to continue broadcasting that transaction, spending the same Bitcoin, they can all say, no, it was in that block. And the reason why it's a blockchain is because the block 797526, that contains the hash of the previous block, right? And so whenever you see a new block with a double spend, the block's hash, the previous block's hash is inside of the block header. And so you knew that he'd already spent that Bitcoin. So you're cheating me. That's an invalid block. The critical thing, right, is that you need a dispute resolution mechanism. You always need to know who's lying, right? And that's the way that you solve the double spend problem. And so that's like why we have a blockchain, of that we need an absolute order of events for the transaction. Because if I'm paying you with the same coins that I spent to my wife, then there's no way for you to stop me from doing that, right? Because it costs me nothing to generate thousands of these transactions. The solution to the double spend problem is that you need a dispute resolution mechanism. You need a way to everybody to come to consensus that this was the truth and those other guys were lying. Does that make sense?
Yes.
Okay. Cool.
And the way Lightning comes into play is because there is as I understand it, jump in when I say this wrong, there's a block size limit, which effectively limits the throughput of transactions. And so Lightning is needed because you need to increase that throughput for like the world to have a viable Bitcoin payment.
Yeah, well, there's a couple things you want, right? So you want instant settlement, right? So Lightning is a way of doing instant settlement instead of having to wait 10 to 60 minutes for the blocks to get confirmed, right? You want to not have to tell the whole world about it, right? And specifically what Bitcoin at the base layer is doing is called gross settlement, right? So if I want to send Bitcoin on the base layer from me to McKay and McKay to some other party or whatever, I have to actually send the money from me to McKay, and then you separately send that money from you to the other person, right?
Right.
Lightning is a system of net settlement, right? And so we don't have to put all of that on chain. We just have to put the net at the end of the day when we decide to close our relationships. So I could do a million Lightning payments off chain just over Lightning, and then I just put the net difference at the very end of all those payments. Does that make sense?
Yes.
Yeah. And so that's like why Lightning. And the other thing for it is that Lightning is like a bearer instrument where using the invoicing system, I can just, with two pieces of information, I can provide proof that to a stateless machine, yes, this is like a satisfactory invoice. This actually did the payment, right? It doesn't need to have knowledge of the whole Bitcoin blockchain. It doesn't need to have knowledge of the rest of the node even, right? I can provide the invoice and the pre-image. The pre-image hashes to the payment hash in the invoice. That is a proof of payment. This invoice was generated by this node and it was paid, right?
Okay.
Cool.
Man, you can go really deep on the rabbit hole here.
Well, it's good that we have this kind of like baseline for it, right? Because it's also like we kind of go into this, and now that we've covered like this is how LNURL works, right? This is how like Bitcoin and Lightning work. It's like let's see how easy it is to add it into an application, right? So let's go.
So let's go back really quick, and maybe before we get going on this, let me provide sort of some backstory on why I am interested in this. So gosh, like 5-6 weeks ago, Cody built with Chatbot UI a solution to the problem that we're talking about at the start of this, which is sort of the API key problem, which is if you want users to basically, if you don't want users that bring their own API key, you need some sort of method for them to make payments for their usage. And right now, there aren't great solutions for like, call it per token API usage.
Yeah.
So one of the things that's really interesting about Lightning, and Cody built sort of an early version of this, is you can use Lightning to basically pay per token of usage rather than having to sign up for like a subscription, having to use, dollars and go through, a third party payment provider on this. And we've talked a bit about why you want that permissionless payment. So I don't know if you want to jump in here and talk about kind of how, particularly for lesser developed parts of the world, why that's an important problem to solve for. So
Yeah, I
maybe
mean,
if you want to hit on that.
this is just generally one. I think that let's jump in. Let's start doing a little bit of code, and then
Yeah,
like
yeah, I
after we
think
do
that's
that, we
good.
can talk about the benefits for it, right? Because like I really
Yeah.
just want to like get the 5 lines in so that we can like make this thing show up,
Yes,
right?
yes.
So let's try this again. Let's okay. Address in use from the shell. So you have to close the shell. No, not your shell.
Yeah.
Yeah, for the shell that you have over there. Yeah, so it's
that should work now.
there, run. There we go. Oh, what's going on here? Started server, could not find a production build. I think you have to run npm run dev, or you could do build too. But yeah, so basically the thing that we're going to do, right, is this is like a super simple way of doing this, is that if a browser has a Bitcoin wallet attached to it, then it'll have window.webln associated with it, right? And so you can interact with that. You can check if it's there, and if it's there, then it's just like a super clean experience of that just pops open in their wallet. They hit pay, and it continues on with what you were doing, right?
And does Alby just injects that into my browser, correct?
Yep. So you can just right now you can just right click. So you can just right click and open your DevTools, right? Or just Command I, right? And then you can go to console and just hit window.webln. Enter. You might have to refresh the page because I don't think you've refreshed this from when you.
Let this script run really quick.
Yeah, or you can just go to a different tab and it'll inject it there.
Perfect.
Yeah. So it'll be there now.
WebLN, yeah.
There you go. Hit refresh. Or do you have to close everything and then reopen?
I know. I'm wondering if it's gonna make me full browser it.
That would be annoying. Yeah, I think maybe let's do that.
Okay. Let's just quit Chrome. Is this gonna? I'm trying to think. Is this gonna boot my stream?
It might. You wanna? What we can do is, well, do you have like Firefox or something? We could just jump over there. No. Can you jump to the? We can move the stream over. It's kind of annoying. I'll get that. Or here.
I could do Firefox probably.
Yeah. You do Firefox and then link your Alby account over there too.
Let me get a
fork the stream.
Definitely more convenient for people if we can just okay, get Alby. Okay, what was the, let's see, Chrome extensions. Okay, it's only available on Chrome. So
okay, here. You know what we're gonna do? Let's just give it a try. You want to switch me to host, and then you should be able to.
Yeah.
Or you could take this, jump over to Firefox, and join from there on StreamYard.
Let's see. How do I make you host on StreamYard?
Settings.
Kick from Studio. Can I make you host? Is that?
I don't know. You want to try opening from Firefox, the same link, and then you log in?
The StreamYard link?
Yeah. So we move the StreamYard over, then we can close Chrome. Viewers, this is all for you.
Yeah, this is what happens when you do live stuff. This happens to me all the time.
It's good though. I love your live stuff. Like, I don't know if I told you this, but like I remember back when you were doing Learn from Anyone. Remember?
Oh yeah. Oh yeah.
That was early McKay.
When you do live things, everything that can go wrong goes wrong. Okay. So I have my StreamYard link on Firefox.
Mm-hmm.
So you're saying I should do
If you close the StreamYard link on Chrome,
okay,
open in Firefox, still logged in.
It should theoretically keep me in here. Okay.
So
let me make sure I logged in though.
Yeah. Let's make sure this works. If it doesn't, then we'll just close and rejoin. You're still there.
Okay. My Mac wants permissions. And now it wants 2FA. Good security. Gotta say that's positive. We always like good security.
Yep.
Confirm. That's Albi. I don't want Albi. Now we need to wait for the 2FA link that theoretically is in my email. See if it sends my phone. It's too bad you can't edit tweets later so you can have the same okay. Let's have them send it one more time. Because we do need the
Are we recording, by the way?
injected. It should be. I have VODs turned on.
Okay.
My other one did it just fine.
Okay, cool.
Okay. StreamYard's not wanting to send the 2FA link. Hold up. I can do
that's okay.
You want to text message.
We can just jump off and then jump back on. You want to just like close out and then come back to the same link, and if it doesn't work, then we'll send a new one.
Yeah, I think that should work.
Okay.
Let's try that.
Cool. I'll stay here and see if that's okay. Hopefully not bye. Okay. We're still going. This is promising. So hopefully McKay comes back. Okay, just texted McKay. Check the chat. If there's anything on. Nothing yet.
All right, I think it worked.
Nice. Okay.
Yeah, my Twitch stream stayed live the whole time.
That's cool. Yep. All right, let's
that's really good.
Let's jump back. Yeah, present on.
Yeah, let me let's see, get this share present screen. No, we want entire screen. Screen one. All right, cool. Drag Replit back in. And then if we go inspect this,
You should be able to do window.webln.
Window.webln. Boom.
Boom.
We did it.
We got it.
All right, we're back in business. Thanks for
Totally
being patient with us, people.
Okay.
All right. So now let's build some stuff.
Yep, totally. So let's hit run again. Let's see if we can get this chatbot UI to actually show up. All right, so npm run start. I don't know what's going on here.
Let's see, we're getting something nasty here.
Yeah. Could not find build. Can you change the run command to dev instead of run start or whatever it is? If you go to if you go to the .replit file.
It's way down here. .replit file, npm run dev.
Try that. PNPM.
Oh, is it a PNPM weird thing going on here?
I think it's working-ish. Still compiling. Yeah. Sometimes it just takes a bit. I think it should be good.
Sometimes this happens too.
Can you open the console? And if this doesn't work, you can go to chatbot UI because I know that works.
Yeah. You know what it actually might be? I think they use. I'm trying to think. They use PNPM by default in this project, and I'm thinking it's screwing things up.
Is it because of the channel? You want to pull? Yeah, I'm thinking we just jumped to chatbot UI. Have they confirmed that it works on Replit? I know it's Vercel, and they have.
Okay, we can just do a new REPL here. Let's clone from this URL. Yeah, clone from URL. Let me get you invited to this.
Yeah. We can add a lightning donate to your page as well. Sweet. Okay.
Trying to think what the best way is to get this running on Replit.
.sh. I've gotten it before. So if you go to just do npm run dev from the shell. npm I. Yeah.
This is probably
yeah, you have to change the run command. Yeah. Yeah, so make sure you kill the shell. There you go.
There we go.
Okay, sweet. Okay, cool. So the first thing for it is that, right, so WebLN is a window object, right? So when we actually do the testing for this, we're going to have to open it in a new tab, right?
All right.
But so the first one is let's set the server side API key, right?
Yeah, so we just need to create a .env file
.env.
here. Local, need that to get out of here.
Yeah, just drag it all the way to the left. That only works.
I've frozen. It's not great. There we go. Or we could just do this. Okay.
Open API key.
go
Well,
grab.
actually, we can get rid of the .env.local and just use the replit secrets. Then you don't have to actually write those down. So you go to secrets, and then you very quickly move off to a different screen. And so for those who aren't tracking, right? So the way that Chatbot UI is set up is that you can either drop it in from the client side, or you can set it your API key on the server side, right? And so if it's set on the server side, then you don't have to do any. You don't have to do. You don't have to do anything on the client side, right? But for the client side one, the reason why McKay did that was so that you could just go to chatbotui.com and then drop in your own key, right? But like,
so what you do is you just go right in here, you drop your key, boom.
Yeah.
Now you can use it.
But so if you don't have a key, or if you want to use somebody else's key, and that's what we're going to do here. So then we go back and the server side API key set. And so if you hit run again, then this should just show the completed thing. Should have been able to read this server side API key.
Boom. Now
Nice.
we should just be able to do test right here, and this should run.
Cool. Okay, so here's what we're gonna do: is like let's go find where it's sending that send, and then we're gonna intercept it with a if window.webln, and then we're gonna get it. So we're gonna get an invoice, and we're gonna pass it back to that, right? So let's go to where's the so when you hit enter or when you hit that send button.
Oh. So you don't need the route. You need the.
I couldn't find Certain in your Apple Music library.
Whoa, what's up with that? Okay, that was my Siri or something.
Yeah.
So if we go to if you go to your components, and then your chat input, I think that's where it is.
Chat input. So it's in here.
Yeah, it's in the top.
Yeah, right there.
There we go. And we scroll and we look for, I think it's like send or something, like send icon.
Handle submit, I want to say. Handle submit.
Cool.
And yeah.
Sweet. Okay, cool. So for that on click, let's like intercept that, right? And so where the thing that we need to do, let's make a new function above that for like get invoice, right? Get invoice.
And what inputs do we need here?
So the only thing that we're gonna have to do, right, is we're gonna have to from a lightning address, we're gonna have to go hit that, get the callback, hit the callback with an amount, right? And so for this one, let's just hard code in the address for this one, right? So let's just take nothing, and then const address equals.
And should we use my address?
Yeah, we can use yours.
Yeah.
So McKay Wrigley.
What was the?
It's at getlb.com.
Getlb.com.
And then we have to send 2 requests against that, right? Okay. And so
this is just going to be a fetch request then to the URL.
So the URLs. So we're going to have to split off the username and the domain, right? So first thing, we're going to have to split off the username and the domain from that address.
Let's do data.
Split on the at.
Then we'll do
username and
let's call this domain.
And enter. And then we're gonna have to build the URL that we're fetching against, right? So like you can do const callback is equal to we fetch. So yeah, we're gonna have to make this async.
You want this as just a string, correct?
Yeah.
Yeah. Okay.
You know what? You sent me an invite for this, so I can just jump in and live code with you. So that's probably the better way to do this. Chatbot UI. So
because we're just building the URL that the demo when we did the display the JSON, we're just doing that in here, correct?
Exactly, right?
Okay.
So callback is equal to await fetch.
Okay. Yeah.
Yeah.
So an actual fetch request here.
Yeah, fetch against the HTTPS / domain in / dot well known / LNURLP / username, right? And so then we have to pull a callback off that, right? So I guess that'll just be a res, right? And then you're gonna have to turn it into JSON and turn off the pull off the callback, right?
So we need.
So that'll be a res.
Okay,
So let's make that a res, and then we do const JSON equals res.json, and then we have to do const callback equal to
just callback.
Callback, exactly.
Okay.
Right. Cool. And so let's so that'll be the callback that we have to hit, right?
Yep.
And so now to get the actual invoice, so we have to do another fetch request. And so that'll be const invoice is equal to await fetch. And that's going to be, so it's going to be callback.
Okay.
Yeah, callback, and then add a query parameter to it. Amount equals something. Like 1,000 or something. Yeah, that's fine. So that's 10 sats. And then you can lowercase amount. Cool. I think the callback has the HTTPS on it. So
perfect.
Yeah. Cool. Awesome. So then you're gonna have to. So you're gonna want to split that off too, right? Because you're gonna have to turn that into JSON and then get the. Yeah. So that'll be.
So let's see. We'll just call it split for now. Typing, by the way, is 10 times harder when you're doing it live.
Yeah. So const split is that'd be await. You have to turn that back into JSON, right? So.
The invoice, right.
So it's not an invoice yet, right? So that's like a result.
Let's just make this a little bit more clear. And then it's just invoice.
It's gonna be PR, right?
PR.
So
okay.
Payment request.
Right.
Yep.
Okay.
Cool. Okay, gotcha. And so now what we've got, if we've got the invoice, right? So if we go back into handle submit, the first thing we're gonna do, so we can just return the invoice.pr there, right? And so I don't think for TypeScript you're gonna have to change the function slug, the function thing, right? So it returns a.
Is this just a string?
Yeah.
Yeah. Or is it a?
What is that? I think it should be a string. Well, let's just leave it there for a sec, and then we'll see what the type looks like. No, that's what it. You have to put it on the right side of the arrow function. No, never mind. Sorry, I haven't done TypeScript in a little bit. That's okay. Yeah, let's just get rid of that, and then
I think we don't. I think it's fine without it.
Cool. Okay, gotcha. So now in handle submit, the first thing that we're gonna do, just to demo this, and then eventually we're gonna have to basically, after we do tick token for figuring out how many tokens it is, we're gonna assign that to a certain number of sats. But for right now, let's just in the handle submit, we're just gonna do the first thing that we do above new content is that we'll set const invoice equals get invoice. equals get invoice, and then enter. And we're going to do if window.webln not equals to undefined. And yeah, so that one, not equals undefined, then we'll do not just not equals undefined. So if it's there,
Okay.
then we'll do window.webln.enable. Then yeah, so exactly that code.
That's check out replets autocomplete. Well done.
Then
or
yes, this is fine. Async, enter. So that's going to be const pre-image is equal to await window.webln.send payment invoice. Okay, and so webln this is just like a issue. This is just like an issue with Replit of that, like its TypeScript language server like doesn't recognize.
Okay, gotcha.
Right, and so so then if after that pre-image, right? So we're going to do if not pre-image, right? So if I get a pre-image back, then it's good to go. Then we just continue, right? But so just if not pre-image, I guess, then we'll return early.
If you want to handle this, we can proceed here, or
yeah. So if there's no pre-image at the end of that, so the user did not pay it with their Lightning wallet.
Okay.
Right? If there's no pre-image, then we just return early, right? So just if not pre-image.
So we just return. So this is saying the user didn't pay.
If you do if not pre-image, then the user didn't pay. But not pre-image is just like a TypeScripty way of making sure that it's like if pre-image is not undefined, right? So for this one, we'll just do return.
Okay.
So if not pre-image, then return. Cool. Okay, gotcha. So stop. Restart. Okay, so then you got to open it in a new tab so you can get window.webln.
It's compiling.
Sweet. And then just try something and click the send button. Okay, can you right click and then see what was going on there?
You need to see the window.webln.
Yeah. You see that in the console? Is it there? Yep, it's enabled. So if we go back to chat input, we go
we log out pre-image maybe.
What's going on? No, so it's not enabling window.webln, right?
Okay.
So let's just make sure. So is it getting into handle submit? Can you console log the invoice?
Yeah.
Right there, 235. Okay, should be working now. Why is it not console logging?
Are we in the wrong?
Are we in the wrong handle submit?
Handle send. Handle sends probably.
There you go. Okay, cool. So let's move that around.
Right, we will take all of this here.
Yep.
And
move that.
Move that up to handle send. And that. Okay. We want this
right at the top.
And then this should be good.
Yeah.
Right. It's important to put your code in the right function.
Yeah. Okay. Cool. So now chatbot UI. We hit refresh.
And okay.
Boom. All right. Cannot read properties of undefined. Reading enable. Okay, you have to await that. There's the issue. It's undefined at that point. So we have to await.
Wait. The window?
No. So let's do.
No, we have to await the get invoice. Sorry. That's
There
where
we
we're
go.
going wrong.
Okay.
Yeah.
And async function. Make handle send async. Cool. Okay. Cannot read properties of undefined. Reading enable. Is it not injected yet?
It's refreshing, so I think it's
Okay.
just build.
Gotcha. Cool. Test.
That should work. Okay, there's the
There it is. Okay, so we got the invoice. So if window not equals to undefined. Window it's WebLM.
WebLM.
Yeah,
Oh, I see.
WebLM. There we go. All right.
Is lightning, not lightning.
Yeah. Beautiful.
Ah,
Okay, cool. So if you unlock Albi first, so yeah, unlock that. Sweet. So it's asking you to connect, right? And so it's saying like, hey, do I even want this thing to be able to interact with my wallet at all? Right.
mhm.
And so what you can do now is you can say, okay, I want you to pay 10. I got an invoice for 10 sats. Okay. So you can just pay it and then it should go through and just continue with what it was doing.
Gotcha.
Right? So, oh, we might have made a mistake there. So let's just go back real fast, confirm that we're, can you take that one?
Okay, so enter a message. Okay.
So if not pre-image return, I think the not.
We need to put this. The rest of this needs to go
That has to go
in here.
Well, I think we should do if not pre-image, right? So
okay. So you just handle it in the one, yeah.
Yeah.
Okay.
Right.
Because it should only stream it if
the user did the payment.
Yeah.
Okay.
And just to break it down, so it's all this is doing is we're checking if WebLN is in the browser.
Yep.
And
if it's there, then
sends off
the connect, send it the invoice, wait for it to do the payment. Right.
Yeah, interesting. Okay.
And so that's just like really, so the way that we're doing it right now is just you have to have WebLN enabled, right? But normally the way that you use WebLN is like if WebLN's enabled, then it's a much cleaner experience and just do it that way.
Okay.
But if
so
not,
this is not sending now. So now we pay it and now it will stream.
Yeah. Sweet.
Perfect.
Beautiful.
Okay.
And so
cool.
you go check your Albi account right now. Right. So go back. There you go. You sent 2 transactions out. And if you do incoming, you got 2 transactions of 10 sats. Right.
Okay. So this is just a circular transaction. Yeah.
Exactly. Right. You're just paying yourself doing this. Okay. Cool. But I could do the same thing. Right. So if you send me that link real fast, then, or I think I might have it already, is that I could do web view. And I could go open this. And now I can do a payment. There we go. And I do test, hit enter. It pops up with my connect and I pay 10 sats. And then I get it. And so you should now have a payment from me.
MetaMask is bad.
There we go. Back, incoming. Sweet. There we go.
Very cool.
10 sats, right? And so for you, if on your donate button, you can just have on click get invoice. And that's all you need in order to start getting payments to that Lightning address.
Interesting. And this is just your Lightning address, correct?
That's just a hash.
Or is that that's
right?
a hash
So
of the transaction?
Like, here's one of the reasons again why Lightning's very good as this payments layer, right? Is because as a sender on Lightning, I achieve very, very good privacy, right? So
Right.
you actually don't have a way, unless I tell you, of correlating that payment back to me specifically.
And
right?
I can't even track what address that came from, or
It didn't come from an address. It came from a node, and the
came
node
from
is
a
using
node.
onion routing. And so if you've ever heard of Tor, right? Tor is the onion router. The way that Lightning payments work when it does the hops along the graph is it does the same onion routing that Tor does, right? And so you know why it's called onion routing? This is like
I
fun
do not.
little thing for your audience. So an onion, because each layer can only see the layer above it and below it.
Oh,
right?
okay.
And
Interesting.
so every hop along the route looks like to that hop that there were 20 hops previously and 20 hops more, right? But so every time, so when you get that payment, you don't know where it came from. You just know that it was real,
Right.
right? So that's like a really cool thing.
Very
right? So
cool.
you get paid by all your users and you don't have to know anything about them,
Yeah.
right? You don't have
This
to
is so like this is just so obvious. You know what I mean? It's just like permissionless payments that are like it preserves your privacy. It settles instantly. It's like what
exactly.
what are we doing here, people? This is so obvious.
Yeah. Okay, but so
Oh.
now like we're coming up on about an hour, right? And so that's like the
Right.
client side, and that's all you have to do client side or whatever, right? And so all
That
that
is
stuff is good to go.
very impressive that like this code combined with that get invoice function we wrote is all you need to do that. That's
It's
very
all of it, right?
somebody who
use
just
that same
learned how to
thing.
code can do that. Like that's not you
Exactly.
don't need any you don't need a
Yeah.
huge technical education to figure that out.
And
Very
so now we can do something a little bit more fun, right? Which is
Can I
like,
really quick? I just want to test it without like so if I reject this, cancel
Mhm.
this just okay, perfect.
Yeah,
So
right.
and obviously we could handle that error better, but I just want
Exactly, right? So
confirm
what
that
you
it
would
didn't
probably
do
do there is you would just set the content probably to nothing.
right.
Right, and then just send like a toast or something that like the rejected the payment or whatever.
Right.
But so here's what we can also do, right? Okay, so do you want to move on to like the server side, or do you want to like clean this up a little bit more in the front end?
Let's jump into server side. Yeah.
Okay.
And
cool.
just if I can chime in really quick. So this is actually super awesome for me because you can imagine as somebody who deploys a lot of these like bring your own key applications where it's like if a user's like trying to get past the paywall here, it's like they have to pay for their usage, otherwise it's not going to stream. So it's
Exactly.
like it's very secure.
And so
which
you
is
can
very
set
helpful.
that function, right? You can literally go like, hey, I want to do the cost of it for my API key. I can do exactly that cost and pass it directly onto the user, or you can do it cost plus 0.001% or whatever, and then you're in the black, right?
Yeah.
And so that's like a super cool way to do it, right? But so here's the problem, right? Is like you're relying on that window.webln object. And so what if in the browser you just like rewrite window.webln and so just like have it handle a send payment and then return like a fake preimage or whatever, right? We're not verifying the preimage, we're not doing any of the checks or anything.
Right.
And so that's why it's just like hey, it's super fast to do that one or whatever, but like a malicious attacker can like get his way around that.
Yeah.
Right. So now what we're going to do is we're going to use something called the L402 protocol. Okay. And so L402, if you go to the Mozilla developer docs and look up a 404 error, just like MDN 404 error, right? So you click on that. What do we notice about 402 on the left-hand side? 402 payment required. It is a established status code within HTTP that has been unused, right? And the reason why it was unused is because they couldn't figure out how to make micropayments work because they hadn't solved the double spend problem.
It even says it's reserved for future use. That's pretty cool.
Exactly. And so
it is very cool that when people were working on the core infrastructure of the internet, they thought about this. It's very
cool. And this is something like you go back to the cypherpunks. The cypherpunks, all of them to a man, was like the holy grail here is money. Like if we can figure out money, we can figure out everything. And so now that we've figured out money, we can go back and we can like fix these aspects of the internet, right? Of like retaining an open internet, making it so Twitter doesn't have to gate everything because they can just gate access to their APIs via these lightning payments, right? And so Twitter is always in the black as long as people are using them. So sure, go ahead, web scrape as much as you want. You're paying me as you do it, right? And so for this one, we're going to piggyback on this 402 payment required error, and we're going to throw back an invoice. Then you pay the invoice and you go back, right? And so we can do server-side validation because we're passing a token along with the invoice. Okay.
Somebody here too, and just really quick. So in chat, somebody said you could also have it remember a budget, so the user doesn't need to click confirm each time. Awesome. And this also ties into the other use case of why I think Lightning and Bitcoin is so interesting with AI is because what you can do is when you're building AI agents, you can give these agents a budget, right? And so it's a programmatic way to give agents access to money so that they can you can feel comfortable having your agent go do something with like an allocated budget. So it's like between the use case that we've been kind of talking about on this stream combined with how this can give AI like accessible money, these are like why I think that Bitcoin can play a very important role here. So it's very interesting.
Yeah, and that's actually something Lightning Labs released today. They released Lang Chain.
Yes, they released their Lang Chain.
Yeah, and I don't know if you want to do like a follow-up to this. We could do like Lang Chain, a Lang Chain wrapper.
I was sent that earlier today, and that was very cool to see. Yeah. So we might have to do a part 2 sometime with agents.
Yeah, totally.
Yeah,
we can get Lalo on too. He's the CTO at Lightning Labs.
Oh yeah, this would be a great stream.
He's super fun.
Yeah.
But so for this one, like what we're gonna do is we're gonna do the L402 payment protocol for this one. So if you go look up real fast, just look up Lightning Blips, like Lightning Network Blips. Lightning Blips. There we go.
Yep.
And there's a pull request open right now for L402.
Interesting.
The Lightning HTTP 402 protocol, right? So if you go into the files changed, and we can go like look at the markdown for this, right? So if we go into the flow, this isn't the best way to look at it. Can you go to the Lightning Labs documentation for it? That's probably a better place.
Yeah.
So you go to lightning.engineering, L402. Just look that up. Look that up.
Builder guide.
Yeah. Okay, cool. So the way the L402 specification works is that what we're going to do is we're going to generate the invoice server side, give it back to the client. The client's going to give it back to us with the pre-image. And then on the server side, right now we can do the verification of like, yes, this is my invoice that I gave to the client. And with the pre-image, I can prove that he paid it. Right. But the problem becomes, this is what we talked about before, right? Is that in the middle of that, I could swap out the invoice and pre-image, right? So like I hit you originally, or I could swap out the body. Sorry, is that I hit you and I say, hey, I have a 2-sentence prompt. You give me back and you say like, hey, it's 30,000, it's 30 sats or something, and then I pay the invoice, and then on the second request that I send you, I attach like a 20,000 token prompt, right? I only paid for 2 sentences, but I attached that big one over there. So how do you do that commitment? So the L402 specification says, I'm going to pass you back an invoice and I'm going to pass you back a macaroon. And so this is actually like an ongoing discussion as part of the spec meetings, right? Of that instead of doing macaroon, we're just going to do generic token. And so we could use a JSON web token instead, right? But a macaroon is just a fancy cookie that allows you to do these caveats. Okay. And so the first thing we're going to do is we're going to set up the invoicing on the server side. And then we're going to attach to the user session like this. We're going to attach a macaroon. Okay. And so when they do the return, we're going to get back an invoice and a macaroon. Does that make sense?
Yeah.
Cool.
Okay.
All right. So here we go. So we're going to take that get invoice function that we did. And we're going to move that server side.
Okay.
Right. So there, that whole get invoice thing that we did, that one we're gonna have to hit an API for it, right? And so maybe the API, let's have that API that we hit or whatever. What we're gonna do is where we're gonna inject this is where you'd normally do your chat.ts API, right? So what we're gonna do is we're gonna have the user, they're just gonna try to hit the chat normally,
right?
But the chat's gonna return back with a 402 payment required, and then we're gonna have client side handling of the 402. And then, so next time they try to hit the chat, then it's just going to attach the authorization header. And so they're not going to get the 402 back.
Gotcha.
Right. And you can leave the chat. You can leave it as part of a cookie, or you can leave it as part of like a user session or something, right? Or local storage or whatever it is that you want to use for it. Right. So next time they hit against it, then it can be like, oh, I've already got the authorization header for it. So you could use the macaroon for doing it so you only pay for the macaroon once. And then it's like, hey, it's got 50,000 uses associated with it, right? Or it's good for 2 days, it's good for 6 days or whatever, right? So
yeah, there's a lot of different directions you could go with that, which is interesting.
exactly. And what's cool about the macaroons too, and this is a big one, is that the macaron, once I give it to you, you can add additional caveats to it and give it to somebody else, right? And so very powerful with agents.
Ah, that's interesting.
Right? So you give the original macaron to the agent can spawn or recursively spawn itself, but with additional caveats on the macaron, right? So it's like you hire the teenager and it can make an army of kindergartners.
Right. Right. That's a good analogy. I like that.
Yeah. Cool. So yeah, let's get into this, right? So we're going to just intercept on the chat. Okay.
Okay.
So if we go to where you call the chat API on the client side.
Yeah. So that should just be right where we did this. What was it? Handle send.
Yep.
And let's see. It's been a while since I've looked at this. On send.
There's an on send function there.
And that is, oh boy, let's go chase that down. Props are great. Okay. Chat. I'm hoping if I did this well, it should just be in here. Yep. Okay. Handle send.
Okay.
Perfect.
Sweet. Okay.
Let me just confirm that's indeed.
Well, there's going to be some place in here that you hit /API/chat, right?
Chat. Actually,
it's not there.
Yes.
Does
Replit have a?
It has a code search. If you put it in just go in the search bar on the left. Search bar on the left hand side. Okay. And then just do /chat/API. There you go. And API.ts. app.api.ts. If not,
what
are you? Do you have a wrapper around that?
Yeah, this is what it's doing here. There we go.
Cool.
Boom. Okay.
Let's get endpoint. Cool.
Yeah,
okay. Yeah. So where does it fetch against that endpoint?
Right here. Okay.
Nice.
This is where that request is happening.
Cool. And so for after that response is where we're going to do the 402 error handling. Okay.
Okay. So after this response, handle.
Yeah. So what we're going to
yeah.
is just if
response.status.
Yeah. Response.status equals
402.
402. Just do alert, like receive the 402. There you go.
Very cool.
Cool. All right. And so now let's go server side.
Yes.
.ts there. And so the thing that we're looking for on this server side is that we're looking for an authorization header, right? So let's go look at the L402 spec real fast.
Yep.
L402. The
L402, the
protocol, the payment protocol. Yeah. So if you go to click on 402, there you go. So if we scroll down, protocol specification there. Okay. So scrolling down. Yeah. So if you look at that first handshake that happens. So if you scroll up, scroll up a little bit. There you go. Sweet. So the thing that we're going to have to pass back from the server is this L402 for under www-authenticate, right? So that's like, hey, if you want to authenticate, I'm using the L402 protocol. Here's the macaroon, and here's the invoice you're going to have to pay.
Here's the invoice. Okay.
Yeah. Does that make sense?
Yeah. And that's why we need the get invoice function, because we have to send them the invoice back.
Exactly. Because the server is generating the invoice, right? Gotcha. And so now if you scroll down again, once they do the payment of the invoice, they're going to create a authorization header, which is going to be scrolled down more.
This one. Right?
Yeah, that one right there. Right. And so see what happened there. That is the authorization is L402. There's the macaroon at the first part. Yep. And then there's a full colon, and that's the preimage.
Okay.
So that's what you're going to do is on the client side, they're going to do the payment and they're going to construct the macaroon with the preimage. Right. And
the preimage basically has the permissions of what it can do.
Well, sorry, the preimage is the proof of payment, right?
Oh,
so
okay.
The way that, because when you gave me that invoice, the invoice contains a payment hash. And the way that you get the preimage for the payment hash is you complete the payment, right? And so if you give me the macaroon, which has a commitment to that payment hash and the preimage, Well, on the server side, I can just hash the pre-image and verify that it is
Okay.
inside the macaron.
Okay,
right?
that clicks now.
Yeah. Okay. Cool. So let's on the client side, on the server side, the first thing we're looking for is, do they have that authorization header?
That's
right?
on headers.
Headers. Get.
And we need authorization. Is that?
Yeah. If it's not there, or if it doesn't pass, like, check authorization or something, and we'll write a check authorization function with.
And we need to check for
authorization, right? On the server side, you're checking to see if they're authorized.
Okay.
Yeah. So if not, let's just, for this one, just not authorization, then like return, we make a new response, then we do payment required.
Okay.
And then you have to do the status code for 402. And so there, and then
the second argument.
It's just like open
status,
the brackets. Yeah, status equals 402. There you go. Cool. So let's see if all that works.
Let that refresh. Looks like I got a rogue. Line 115. Missing like there we go.
Okay.
I'm sorry, I'm doing one extra. We got a rogue syntax error here.
It's all good.
I wonder, let's see, we're complaining here. Cannot find update prompt visibility. What did I change in here?
Did you remove get invoice?
I thought I copied it. Yeah, that looks good.
Get invoice wasn't defined.
Okay.
Yeah. So you got to move get invoice.
You got to move this to go up.
Yeah. There you go. Okay, so that's one issue. And then can we just collapse the parentheses and see what we're missing? Sorry, the brackets. If we go on the here, actually, I'm inside of this editor too, so I can help. So
looks good. Looks good. Looks good.
This one goes there. Oh, you're missing that. Sorry, you're missing this thing. It's a dot then, right? So we gotta
fun.
Oh. Okay. So this one, collapse that if, collapse this if, collapse this if. This if goes to here. This one.
I think we're missing one.
Okay.
One bracket.
Yeah. Okay. It's in the wrong place.
Oh, so here's an interesting question. Somebody said, if as a user they commit to a certain budget, are they at risk of the API service provider maxing out that budget and rugging me?
So it depends. So are you doing a client side budget or a server side budget? Right. And so, for example, so let's go back to the chatbot real fast once we get it running again. Yeah, so there we go. So if you go back to chatbot UI, then hit test or whatever, and then just hit send again. Cool, awesome. So nope. There we go. So receipt of 402. But so if you go, so hit OK again, then go test or something, and then hit, and that's remember and set a budget right there. So that's a client side budget. And so what Albie's doing is Albie's saying, if I just see an invoice show up, then I'm just going to pay it while I'm on this website.
Okay.
Up until this amount, right? And so that's the one where you're at risk for this.
Yes,
right?
yes.
But if you don't set that budget client side, and then every single time that the server tries to make you do a payment, it's going to pop up with that, and you can confirm or deny it, right? Because Albie is like the WebLN wallet. It's not just Albie. You could just use Zebedee. You could use whatever else you want, right? Is acting as like this wall between all of your private key material and the application you're interacting with, right? And so when you do that budget on the client side, you're saying, hey, Albie, just when this shows up, just like let it do it, right? That's the difference there. Okay, cool. So we're getting the 402.
Yeah, that's nice. Right? Yes, 402 is working, which is what we would expect.
Yep. Cool.
And now we need to handle the macaroon.
Yeah. Well, let's first do the invoice, right? Okay. So the way that we're going to send it back, right, is that we've got a status code of that thing, but we're also going to send back an authenticate header, right? Like a www authenticate header. Like if you go back to the protocol, then
this.
See that, right?
Yes.
Cool. So we need to do that authenticate header, and so we need to do L402, macaroon, and invoice, right? Is what we have to send back. Okay. Cool. So if we go in here, then so we're doing on the handler, we're doing that 402. So the get invoice, we call that. Yep. And so we can move that outside. And there we do. Yep, there we go. And then, so if there's not an authorization, then we have to do like get L402, right? And so above that, we'll do const L402 is equal to get L402.
Is equal to what?
Get L402. We're going to make an L402 function.
Okay. So the function that doesn't exist. Okay. Right. I was like, I don't remember.
And up top, we're going to do const get L402. Takes nothing. Goes async, right? And so the two things that we're going to need for this are a macaroon and a invoice. But for right now, let's just have the macaroon be hard coded to something, right? So let's do const invoice.
Okay. Const invoice. So we need to get the invoice. Which we'll await that. And then we're going to hard
code it to something so we can pass it back.
Okay. This can be anything, right? This is just,
Okay, cool. And so then we're going to create the L402, right? And so that one's just going to be, that's going to be like a string. And the string, well, let's go look at the protocol real fast for it. Is it a string or what is it specified as? So the L402, it's going to be in the header. In the header fields to indicate the L402, the macaroon needed for the client where AGI's macaroon, paste the invoice for the server, and then constructs the L402 by concatenating the base with a single colon and the hex encoded preimage. Okay. Gotcha. So let's just make this a string for right now. And I think there's probably a better way to do this, but let's just for right now do it a string just because we can do that, right? So const L402 is equal to like backtick, right? Then we do L402 space macaroon. So capital L for that one, and then lowercase m. This is not the best way to do it, but we're just gonna macaroon equals macaroon. Macaroon. And then invoice is equal.
Was there a comma or?
Yeah, there's a comma there.
Yeah. And we need just invoice or invoice equals invoice.
Yeah. Invoice. There you go. And that's what we're going to return, right? Sweet. So that gives you the L402.
So we're just returning this to the client.
Yep. And so we got to put a header on that status code that we return. All right. So get response. And then the header is going to be equal to www-authenticate. Right. So comma space header.
Headers, and then this is just going to be that.
That's going to be L402, and that's going to be www-authenticate. No, sorry, the other one. Other way. The header's called authenticate. Yeah.
And this is our L402.
Yeah. You can just call it L402 because you did it there. Yeah, and that's going to have to be async. You're going to have to await that L402. Not there.
Oh, yeah.
It's all good. Cool.
Yeah, more record there. Okay, there we go. So
on the client side, you should be receiving that authenticate header. And so let's add a console log for that and see if we get it.
We want right here. We want to log the response. I'm like making sure I knew what was going on here.
Yep.
That matches up with this. This is the header we
also,
passed
we're
back.
like implementing this from scratch. There's like NPM packages we could use for this, right? But this is like an educational exercise. So.
Yeah, well, I think it's helpful for people, especially myself, to do it as raw as you can the first time, so you actually understand what is going on. Okay, so this should work now. That's our invoice. Here's our response on the headers.
There's I think you can't see.
I think I have to actually log.
Yeah, you have to log.
What you can do too is just check the network request. Even
that works too. Go to headers on the back one. Response.
Should be getting 402.
Boom.
And then we should be getting
Beautiful. All right. So you see that? You got the L402, the macaroon, and the invoice. Okay.
All the reports here.
Cool. So now we're gonna before we do this, just because we're gonna do as much as we can before actually doing the macaroon handling.
Yep.
Let's handle the payment on the client side.
Okay.
And so for that one is going to be if the response.status is 402, then we're going to look for if there's an LSAT in there, right? And so we'll do if like is LSAT or something, right? Is LSAT, and then we can define that is LSAT.
That right above here.
Const is LSAT equals async. It's not. It doesn't have to be async.
I don't think it is, right?
Yeah, that takes the requests.
And we're gonna cheat.
Okay. Yeah. So for this one, we're looking for what's called if you got to do request.headers.get www authenticate. Right. And then or you could just return it's got authenticate and it starts with LSAT or whatever. Right. Mm-hmm. So let's just do it that way.
So we have to wait. So we have to check that it's.
So if it has a www authenticate and the authenticate starts with LSAT.
Okay.
So it's using the LSAT protocol for this. And Lalu, if you're on the stream, because I think he's on the stream too, you can tell me if I'm implementing this wrong or whatever. But like this is as I read the protocol, what you're supposed to do.
So how do we get the LSAT?
That starts with LSAT. Right. So let's pull off the header first above that. Right. So let's set it equal to like a const auth header or something. Get www authenticate.
Then if this starts with
and header dot starts with is it starts with or it's an any, so I can't remember, but so that's going to be a string at that point. right? But so and you're just going to do if like
It's all caps or lower? It's lowercase, right?
it's uppercase. Yeah.
Uppercase. It is uppercase. Okay.
Oh, sorry, not LSAT. Oh, sorry, L402. L402. My bad.
Okay, that's where I got tripped up a little.
Yeah, there is. It used to be called LSATs, right? And then a certain someone who happens to be very picky about the name LSAT decided that it could no longer be called LSATs.
Yeah,
And,
I can see why that happened.
So yeah, so we get the authenticate, and so
okay. That makes sense because I was like, in my head, I thought we were checking for this.
yes,
like,
that's
okay.
It used to be called LSATs, but now it is no longer called that.
I follow now. Now. Okay.
And so for it used to be Lightning Single Authentication Token.
Gotcha.
But for yeah, so here, so if it's authenticate and starts with L402, then we can do window.webln.
Okay.
Right?
Right.
So we have to strip off the invoice and the macaroon for this one, right? So let's
off of the header in here.
Yeah.
Okay.
Right.
So we want to return the invoice and the header.
So well, we just want to get the macaroon and the invoice out of it, right?
Okay.
So I would const destructure off like macaroon comma invoice. And then we can make a function called like decode L402 or something, right?
Header.split. We want to split out. Let's see.
And I think is LSAT, we were just doing a true or false, right? So this would be separate. That's okay. Yeah.
Sorry. So we want to pull here. We want to return the macaroon and the invoice.
Yeah. So we need to decode that string, right?
Right. Okay.
Yeah. So we can just do a quick function for that one, right? So it'd be like, no.
You can split edit space, right?
So that should be
because the macaroon would be
split on the space. That'll be L402 macaroon invoice, right?
Right. So let's
I think we should pull that out into a different function.
Okay.
Yeah. And then that is LSAT. It should just return true false. Right. So return true.
Just tab that.
Yeah.
Okay.
False or whatever. So return false at the bottom. Otherwise, it's not gonna. Yeah, return false. Okay, cool. So const decode LSAT. Let's do that. Equals. Yeah. And oh, how about we could just return the header, right, from the is LSAT? Or no, that's fine. We'll just do true false. So decode LSAT takes a string, and that's going to be the LSAT, right? Header string. Call it the LSAT.
Yeah.
LSAT. There we go. And then we can do. So we got to decode it, right? So we can do like parts or something, right? So like const parts.
Just jumping my input over to the send box. Parts, okay. And then
LSAT.split on. You can do error handling eventually, but for right now, we're not going to do that. It's split down the space. And then we can go to this next one. We can do return as like a dict or whatever it is. We can do parts 0 and wait, sorry, we got to destructure off. Yeah, we got to pull off the macaroon equals, and we got to pull off the invoice, right?
Because you just want the mac or
so that's gonna return like macaroon equals and
right. So you just want
right
this, correct?
Yeah, I think that's what we want.
Yeah. Okay. So we could even just get really janky here and go.
Yeah.
Are the equals? Is that part of the macaroon?
Yeah, so that's a base 64 encoding, right? And so the equals at the end or whatever is just, I think it's just filler in order to get the byte limit, but it's like
all right, we're gonna get real janky here.
No, I would recommend that we do it slightly differently. So we go to if we go up, we do const macaroon equals, and then we can like strip off that macaroon, right? So we could do split it on the equals, and then we can get parts 1. Sorry, and then we get 1 off there. And then we should replace the quotation marks. That'll probably be there too. That replace the quotation mark with
quote.
Yeah, backslash.
Here.
Or you can do that one too.
Is
with nothing. And then we can do const invoice equals that one.
Invoice of, yeah, okay.
Yeah, it should be the exact same. Okay. Sweet. And then we can destructure those off and just console log them and see if that works.
Oh, and where are we doing the decoding at?
We got to do that inside the error handling, right? So if it is an LSAT, then we pass the LSAT to that function.
Okay, so if it is LSAT,
yeah, so we can do.
That's passing in the header, correct?
That's passing in the
request.
Response.
Okay.
And so that should be res at the top too. But
yeah.
So if it is an LSAT, then we can do.
We want to destructure
macaroon invoice, like destructured off.
And that was called decode LSAT, correct? And we're passing in the LSAT, which is
so we're getting the invoice back, right? And so if we go back down, so for this one, we should be passing in response.headers.get that one. Here, you know what? It's because we're not doing the check inside of here. So we could do above, we could do, we could get, so const LSAT above that. We could do, no, not there, but below then the response.status. It's a little janky, but we can just figure this out. We're kind of doing this on the fly, guys. So we do const LSAT equals is LSAT, and then have that return the LSAT. Right? So there we can just have it return header. Right? And then we can do a check. We can do not. So then in the if not else. If else, let's make a response. There we go. And then get rid of the is LSAT. It's just if not LSAT. Oh, sorry. And we should be calling it a 402. That's okay. Can we just copy, do Command D or whatever? Just have to
L402.
Sorry, I'm so used to LSAT. It's so long. And it is LSAT is missing one right there. That's
then decode LSAT, we should just be able to pass it in LSAT here.
Yeah. And we should call it
or L4.
Yeah. See, now I got you doing it too.
This has been
the college
my confusion in the last like 15 minutes of this is like trying to.
Sorry, my bad. Yeah,
no, you're good. It's hard to get used to.
College board's gonna come after us now. Okay, that's so funny. We're gonna decode. If we need to change is LSAT and is L402 to is L402 and decode L402, right?
Should be we should be all good here.
Command F LSAT and then I should find it. Yeah, there's 2 more places that we got it. Yeah, so is L402. And then there we go. Should be it. Sweet. Okay.
Okay. Very cool. So now we should be able to log these out.
Yeah. Sweet.
Okay. So we're going to make a chat request. It's going to check for the macaroon essentially, right? Which is the authorization.
Yep.
It's not going to be there, so it's going to throw this payment required response, which is the 402 error.
Yep.
And then we should be able to log that out, which is we got both of those.
Nice.
Because that's our hard-coded macaroon.
We have to strip off that comma from test, but otherwise that's it. Right. So off macaroon right there. Or decode macaroon.
Was
decode L402.
This right here. We need to replace. We'll just be really nasty with it. Just replace the comma with the thing here.
There we go.
Cool. All right.
Yeah.
We're getting places.
Sweet. And I think so. We destructured the whole macaroon just to like remake it at the end of this, right? But so now that we've got the invoice, we can do the exact same WebLN thing for right now, right? And so the way that you normally handle it is that if WebLN is there, then do that. But if WebLN's not there, well, then we're going to like show the invoice as a QR code in a modal and then poll against that verify URL until it gets paid.
Interesting.
Right? Is like one way to do it. And so if window.webln is not undefined, then await window.webln.enable. Enable, and then const preimage, destructured preimage, right? So is equal to.
Sorry, this is the same thing we did in here.
Yeah, you could take exactly that same code, right? So like all of that window.webln thing, right? So all of that there, right? And see, we've got the invoice.
Right. So we don't need
Yeah, but so just get rid of that messages streaming and all that kind of stuff, I think, right? Or
yeah, we don't want this.
Yeah. That's not there.
Yeah, we don't want that. Sorry.
Yeah. If not preimage, I think we just return. Or sorry, if not preimage, that means that preimage was paid, right? So we do want to continue with what we were doing. So if we get the preimage back, we want to continue.
Okay.
We do want that stuff. We do want that stuff, I think. Don't we? Sure.
Well, this isn't doing. This is, let's see.
That's in
handle. These are different components here. So we want to proceed with all the stuff it's doing down here. Is what we want to do.
Okay.
So I'll just grab all this. Wow, that's nasty.
Yeah.
Want
to move them one at a time?
Is it a use effect? Is that really how I'm doing this? Boom, and then we need there we go. Okay. So this should fail. That's our 402 error, which is just being handled really poorly on my end of the UI.
Yep, the macaroon and the invoice looks correct.
Those are correct, yes.
It's not calling window.webln.
So it's window. Did I do M this time? No.
No. Can we console log inside of that? So is it getting into there?
Okay, so it is enabled.
Is getting in there. Okay, so what's going on here? So, await, window.webl.enable. Nope, we've got it in then.
It should be the second one, right?
Yeah. How about we do console log
Plug this pre-image here.
image?
Feels
I think you have to
right,
destructure the image, but I might be wrong.
Off of
send payment. Like,
okay.
I'm not sure. Okay. There we go.
And you would be right.
Oh, because you got so this is what's happening. It's doing the payment in the background. Remember, we enabled that budget with Albi.
Oh, is that what's going on?
Let's
Okay.
go back up to Albi, right? So then go see there. Yep, see, it's got up to 90 sats. And so
Gotcha. Okay.
Yeah, so let's go click away and then click back in. Click back in and then do settings on the right hand side. Delete. Boom. Okay, cool. There we go. So do test. Let it connect.
Now I'm giving it approval for one transaction.
Exactly. I know. Oh, okay, cool. So we're not passing back the correct macaroon with the pre-image now, right? So we're hitting it again on the retry.
Right.
And so it's still not satisfying that 402 payment required. And so now we have to let's just, before we make them real macaroon, let's just attach it to test and then pass it back in, right? Let's just make a super basic macaroon verification for it, right? So if we go, yeah, cool. So if we jump out here, so if not response dot okay, then field loading false, and because that's what it's doing, because the response is not okay. We don't have the retry logic inside of there, right? So let's go back. So here, once we get the pre-image, then we have to reconstruct the. Sorry, there was a spider. So once we get the pre-image, we have to construct the authorization header that we're going to hand back, right? So we hit the server, it gave us the L402, we did the payment, and now we have to make the authorization header that we're going to pass back in, right?
Okay.
And so that's a client-side operation. So we can go back and chat, and for right now, we can just do for this one. So if not pre-image, so it did do the payment, then we can do. Sorry, you're right. It's right there. That's fine. What you have. Yeah, if not pre-image, return early, right? Okay, cool. And then if not pre-image, then we have to make the authorization header, right? So const auth header equals, and this is going to be
same. This is the same thing we did here.
No, it's a little different, right? Is we don't have to pass the invoice back.
It's right? Okay. It's this one.
What are we doing? We're passing back L402 and just the macaroon. And so that macaroon, what we're originally doing with the macaroon, right? The macaroon has a commitment to the payment hash in the invoice, right? So we don't need to pass the invoice back. The invoice has a bunch of information like route hints, what node you're sending it to, all that kind of stuff, right? The only thing your server needs to know at this point is, did they pay that invoice? Well, the macaroon that you generate is going to commit to that same invoice. So when they pass the pre-image, it's going to check that it commits to the same payment hash inside that macaroon, and then you're good to go, right? Macaroon colon, colon, and then you need the pre-image there.
Let's see, is the syntax correct? Yeah. Okay.
Cool. All right.
And then we need to,
I think so it should just say L402. So the auth header should be it's called the key should be authorization, right? And the value is L402.
Gotcha.
Right, and so
then
so then below there, in the error handling that we have there, right? So go back up. My bad. Whoa, what's going on there?
Spazzing out here. Okay.
Okay, cool. So that's the auth header that we have, and so we have to do retry logic now, right?
Okay.
So we just did the auth header, we did the payment, and so now below that, we're going to do the we're going to reset what response is there, right? So response should not be a const. Response, you got to go up, change that to let, and then you're going to try again that endpoint with the auth header.
Where's this should be?
Yeah, set that to let, and then just try that same call again.
Okay. And that needs to be done here.
Yeah. Equals fetch endpoint.
And this
exact same thing that you had before.
Yeah. Let's copy paste this. We need to throw on the auth header.
Yep.
And is it www authenticate?
Nope, it's just authorization.
Authorization. Okay. And that should have our auth header on it.
Cool.
And bodies.
Okay. So then now we've got enough that we can do on the so here now you've done the first call, right? Mm-hmm. And so that should be good to go, right? So now let's go back on the server side and let's just check that if they send back an authorization header and it contains what we thought it would contain, then we can just let them continue.
And it should contain the macaroon.
We call it like what's it called? Like author. We can have a function or whatever, right? So like auth is valid or something, right? Const auth is valid equals that takes the
header.
Yeah, that takes the header. And so we're going to do a couple things for it, right? So the first one that we're going to do is that this should just be like test : preimage right now, right? Mm-hmm. And so we can just say, what's it called? It's like if header dot starts with, no. So let's destructure it off, right? So let's break off the macaroon and the preimage.
Okay, so we're going to need to pass in.
So const macaroon, comma, preimage.
Like the header's not an object though, right? Or is it?
The header, as you're passing it right now, should be a string.
It should be a string.
Yeah. And then so we have to do that same thing of breaking out the macaroon in the invoice, right? But they don't have the macaroon equals in the invoice equals.
Right. So that looks like what?
So that looks like header dot split. On the space first, right?
And that's going to be the...
And then on one, again, this is going to be super janky. So we can pull off...
the second one's the pre-image.
Yeah, right? And so the macaroon's going to be so that's going to split. You're going to have LSAT, then you're going to have off that first split, right? From the space. And then you're going to have to split again on the second thing off there. Right, so dot split on the colon, and that'll give you.
Okay, and then okay. I was thinking this was a space. That's where I got messed up there. Okay. Yeah, that makes sense.
Cool. And then so let's just destructure those, right? So on the const, do like open bracket macaroon, comma preimage on that first one. Does that make sense?
On this one?
Yeah, just do colon. I'm sorry, do bracket. No, not bracket. Sorry, brace. Or sorry, bracket. Yeah, those are braces.
macaroon, comma, preimage. And then you can make that as brackets, not braces. That should work. I think that would work, right? Or no, not the one at the end.
Not the one at the end.
Yeah. There you go. Cool. Awesome. Sweet. So now let's just have a super basic check, right? Of that, we're going to check that macaroon is equal to test, and then you just do if macaroon dot starts with test. Let's just return true, right? Else return false. Yeah. And is like auth is valid with the that first thing.
It's gliding at me. Oh, it's in case it's null.
Yeah, so just do a const above it, right? So all that requests.headers.get stuff, just do like a const auth equals that thing or whatever, and then do that above. Sorry, so scroll up, move const that to like line 58 or something. Does that make sense? Yeah. Cool. If auth and auth is valid.
That should be good now. Yeah, there we go.
And then you can change that rec.headers.get authorization to 60 to just auth, if not auth. There you go. Cool. Okay. And I think at this point, you should just be able to do auth is valid auth. You don't need to do that second auth check.
Right.
Cool. Okay. Sweet. So if auth is valid, then we should just continue. Or I guess we can do here, we can do if not auth is valid. We can do like console.log alert or something, right?
Yeah, we'll say about auth.
Yeah.
Keep it simple for now.
Okay. All right. So let's go back to the other page.
Look at all these transactions.
Yeah, and it's so clean, man. I mean, it's like Lightning's instant. Lightning works.
It is very clean.
Okay. Cool. So let's go to test.
Okay. Proof payment.
Oh, all right. Something's failing. So let's go back to server side. What do we see? Can we do?
Okay, so it's payment required, so that's working.
Yep. If
auth is valid, invalid auth. Sorry.
It doesn't seem to be console logging that there.
No.
So do we have the retry logic in there? So is that can we do console log the headers? Right, so like the second log. Sorry, not there. Like
there.
above that, like where it does const auth or whatever. Can we have like log the header right there? Yeah, everybody knows console log is how we debug.
Authorization spelled right. Okay. Null. Okay, fun. Rec.headers.get authorization.
Yeah. Sorry, one sec. Somebody in the chat was like, "Hey, do you need Albi for the L402. So you need Albi for the macaroon because the macaroon is going to be stored as part of the session, right? And so like within the browser, that's where it'll be. You could just pass back an invoice and have them pay the invoice, right? And then have it.
Right.
Well, yeah, you just need something on the browser that can store that macaroon, right? And so you could put it in local storage or something, right? But yeah, so you can. So if there's no WebLN, you can show a QR code, and then they could scan it with their phone, for example, right? Yes, Lady Thatcher, that is what we're doing right now. So cool. Let's go back in. So where are we?
Okay, so this is null. This is basically what's happening here.
That's null right now. Okay, gotcha.
Yes.
So why is that null?
Is it null on? Are we sure it's hitting it twice? So on the first one, it should not be there, but on the second one, it should be.
On the second one, yeah, okay.
Right.
Yeah, so it's not hitting it the second time.
Okay.
So getting mixed up here.
that
So on the second request here,
Yeah, can we console log that response? See what's going on there. Like, yeah, so that'll be on the client side. Okay, so then we hit pay. Okay, response. What do we got there? So that's the second one that we're doing. You go back to. Oh, are we not attaching the author? Oh, we are.
okay, so the pre-image is coming back as an object is what's happening.
So we have to destructure the pre-image.
Yeah, so we need to do sorry, where are we doing this?
Wait, where's it coming back as an object?
So we're logging.
Object. Oh no, that's what I was saying, right? On the client side, you have to destructure the pre-image. That's what I was saying, right?
So
that's
we
the
need
issue.
to do okay.
Yeah, so pre-image is
happening.
equal.
Sorry,
we have to destructure it off. So that is.
This is right here.
Pre-image. There you go. Yeah, you got to wrap that. Cool.
This should work now.
Yes. Okay.
All right, we should be good to go here. So pay now.
No. Okay. One sec. Sweet. Okay.
That works. And then we are getting, yeah. So now we're getting the pre-image back there. Very
beautiful. Cool. Beautiful. Okay. Cool. So I know it's getting late. Are you good to keep going, or do you want to roll doing the macaroons to a different?
So I can go like 20 more minutes if you.
Okay, I think we can. I think we can do this in this 20 minutes. Okay. So here's the thing for it, and this is like we did like a whole very deep walkthrough of this, of implementing the whole protocol for this stuff or whatever. There's npm packages you can do that just do this out of the box, right? Of just import L402 from Boltwall or whatever, right?
Yeah.
And so the thing that we're going to use here is we're going to use macaroons. And so macaroons are just fancy cookies. Is the idea behind the macaroon. And so
it's a great name.
Let's go find a macaroon library that we can use. So if we go to npm or macaroons npm lib or something. Yeah, macaroons. There we go. Right. And so for this one, let's make sure that we have a good example here as well. Right. So we go to GitHub. They have a good example as well to make sure that we're
just 4 years old, so I'm a little.
Well, macaroons got released a while ago, and so it might just not whatever, right? So we could do it. So we can do it. We're gonna try it with macaroons, right? But we can also do this with a JWT if we wanted to, which is just super easy to do with JWTs, But yeah, so let's let's do it. Let's roll the dice. We'll see if we can do this. And so because I've never used this JS side macaroon library either. But so
is there one you prefer, or
I normally don't write in JavaScript, right?
Okay.
Yeah, and so I normally don't use that, but it's fun. So let's just go to or actually a good place where we could go see this actually working is in Bolt Wall. So if you go look up Bolt Wall real fast.
Bolt Wallet?
Bolt Wall. So Bolt Wall is a really cool way of doing an Express server. Bolt Wall, LSAT, or whatever. Yeah, there we go. Bolt Wall. Cool. This one's going to call it LSATs, right? But because that's back in the day. And so if you scroll down and go look at the way that it works, see where they implement the Express server there. So like I was saying, there's a super easy way to do this with NPM packages. Like that's the entire process of doing this whole thing, right? So see where it says it applies the middleware of app.use wall. That means everything below there has 402s. That's like the entire process making Lightning payments for your API.
Nice.
Right?
Okay.
And so we just went through that whole process, but it could have just been app.use Bolt Wall and just put the API
Gotcha.
Right?
Okay.
If we wanted to. But so let's go into the Bolt Wall code because I know he uses macaroons inside of here, right? And so we can go look for the way that he's doing that.
Okay.
Server.ts. Look for some place we're called macaroon. Not there. Okay, back.
Next, maybe.
Macaroon. Oh.
What about does he do? Put in a helper.
Macaroon. There we go. Import star as macaroon from macaroon. That looks promising. And so then.
Yeah, there we go. Okay.
Cool. Okay. So how does he do this? This is connecting to a Lightning node using a macaroon. That's what he's doing here. So if we just keep scrolling down, so I think he's just using the macaroon here for connecting.
Request an invoice, generate new LSAT.
Yeah, where does it build the new macaroon? There we go. Builder.new macaroon. It was somewhere over there. Macaroon.new macaroon. Sweet. Okay, that's exactly what we need.
Okay.
Cool. So we're gonna want it.
We're going to want to install this.
Yeah, npm install macaroon.
Okay. Very nice. And then we want to essentially just we want this right here.
Yep.
And we're wanting to do that in.
So this is where we're going to have to, on the server side, right, is when we're getting an invoice and we're getting a macaroon. And so the first thing we're going to need is the invoice, right? Because the macaroon is going to have to commit to the invoice, right? And so where do we have the invoice here? We're getting the invoice under get L402. And so inside the L402 function is where we're going to need this, right? So const macaroon, I think that's the one where we're going to need
this is the one. Okay. So we want this here.
Yeah, so builder is going to be equal to that. And then builder, we're going to add a caveat for that invoice. And so the way, I think we could just do it nice and simple right now. We don't have to do the whole, I don't know, we could take a stab at it or whatever, right? But we can just caveat of committing to the entire invoice. You don't need to commit to the whole invoice, right? You just need to commit to the payment hash because the pre-image goes in the payment hash. So actually, we're going to need to destructure it anyway. So maybe let's do that one. So there's an NPM package called Bolt 11.
Bolt 11. Okay.
Yeah, bolt11.decode.
.decode. Okay.
So because it's called a Bolt 11 invoice, right?
And you're saying there's a function. Okay.
Yeah, there's a function called bolt11.decode, and you pass the invoice in, and it'll destructure off all of the different tags for it.
Okay, so we want to get rid of
that. No, so we're gonna need both. We're gonna need both.
Oh, we're gonna need both. Okay.
Yeah, because what we're doing, right, is that the invoice is this very long thing, right? So maybe let's just for real fast, we can go back to chatbot UI on the client side.
Yep.
On the client side, sorry, the different tab where you have it.
Yeah.
And then just grab that invoice real fast. Oh, never mind. Okay, just do that.
Okay, this invoice.
Yeah, just copy that thing and then just Google like decode invoice or whatever, right? There's like a website that lets you do it. Lightning decoder, sweet. Drop that. Cool, right? So that's all encoded inside the invoice, right? So the amount that it's for,
very cool.
hub key that you're sending it to, the signature over this invoice, there's a payment hash and a commitment hash, right? And so the thing we want is the payment hash, because the payment hash is equal to SHA-256 of the pre-image.
Okay.
That makes sense? And so when we're verifying this on the server side, we have the macaroon, which has the commitment to the payment hash, and we have the pre-image. And the check is going to be that the server is going to hash the pre-image and assert that it's equal to the payment hash. Does that make sense?
So we need to decode this payment hash.
Exactly. Well, we need to get the payment hash out of the invoice. So that'll be const, and then call it like I think destructure. We'll just do const decoded invoice, I guess. Invoice is equal to bolt11 dot decode invoice. That should work. Oh no, sorry. That I think you copied that in wrong. Right? Is that yeah? So
not
just
the payment
invoice. Pass the actual invoice object in.
The invoice. Okay. So we want this one.
No. Sorry. So go back. Like we have a constant called invoice on the in the code.
Oh, we already have it. Okay. Yeah, okay. So we're just passing literally this invoice.
Yeah. Right. So that's going to be.
We want to do the
bolt11 decode.
Decode. Invoice. Passing in invoice. Okay.
Yeah. Did we install bolt11? I think we did. Right. And so hopefully this works.
We should be able to import it. Import.
Or can you go to the npm bolt11?
Yeah.
It's in there somewhere.
Okay.
Yeah. Decoded lightning payment request dot decode. Right. So import star as bolt11 from bolt11 would be the ES6 syntax.
Okay, and then we want
that's going to be bolt11 dot decode. And that's going to be bolt11 dot decode invoice.
Oh, just decode. Okay.
Yeah, that should work. And so let's console log the decoded invoice. Yeah. I believe that's server side. So that's where this log's going to be. Sweet. So you should be able to go back.
Okay.
Build failed. Reading from Node Crypto is not supported by plugins.
Okay, so what's happening?
Okay. Yeah, so this is what's going on here, right? Is that I think this is like a Replit specific thing. Is that Replit you need to backdoor your way into using the crypto library, right? Because the crypto library uses buffer, and buffer doesn't exist in the browser unless you define it, right?
Gotcha.
And so this is something that's like we're running into like a Replit specific error as it applies to this, right? Because you don't. So we're gonna have to this would be like a bunch of little hacky solutions in order to get around that, right? In order to do that. And the reason why it's doing that is because when we try to decode the invoice in this way, like it's trying to, as part of the decoding invoice, right? It's importing the crypto library so that it can make the so that it can get the signature and verify the signature.
Okay.
Right?
Okay.
Yeah, so that's what I think is going on right now, and so that is like super hacky to get around, and so it takes a little while if we wanted to do it that way. If we wanted to use this bolt11 library, we'd have to do that thing, right? And so I think actually, I think because we're coming up on the time that you said that we should stop it, so I think this is like a good stopping point in terms of the thing that we would do next is that we would use this macaroons, right? And so the macaroon would commit to the invoice, and then when you pass it back, you have the macaroon, the invoice, and then nothing would change on the client side at this point.
Gotcha.
Right? Is that the only thing that we're doing right now is just doing the server side validation, and the server side validation would be using these macaroons, but we don't have to use the macaroon. We could use like a JWT, right? But like I think it would be worth doing. Like,
so what's the advantage of using macaroons then?
Okay, so macaroons specifically, they're fancy cookies that you can add caveats to. And so I can give you a macaroon and you can add additional caveats to it and issue new macaroons off that same one that I will be able to recognize without having to talk to you. Right. Mm-hmm. And so this is like, originally, I didn't think macaroons were all that important for this stuff. Right. But the advantage of it is agents, because the agent you can give a root macaroon to, and then it can call sub agents, which it gives additional caveats to. Right.
Gotcha.
And it doesn't
somebody in the chat, they said, sounds like an agent that uses some non-browser based client could save its macaroon somewhere and pull it into working memory to reference it anytime it needs to make a payment, which sounds like exactly what you're talking about.
Right. And this is like the thing that I think is really powerful with this is like basically think about recursive agents, right? Of like, I think the analogy before, right, is like you purchase, well, you don't purchase or whatever. Like, purchase is a bad word for the analogy I was about to say. You're about to purchase a teenager, right?
Yes.
You purchase these services.
I follow.
Of someone with a teenager intelligence, and that person with teenager intelligence and the wallet that you gave it can go like make an army of kindergartners that is kicking off to go do these things and allocate its resources among the kindergartners, right? Because you're only adding additional caveats. Is whatever restrictions you gave that first agent, it can only add additional restrictions to the agents that it's calling. Right?
Right.
Yeah. Does that make sense?
Yes, it does.
All right. So I think this was super productive for this one. I think that we did a good overview.
This is pretty impressive how much under the hood we did.
Yeah. Do you want to just real fast, because this is the thing that only takes like 5 minutes, is we could go to your the new thing that you did in your donate button, right? And we can just add a WebLN check to it, right? And so like, do you want to go jump over there real fast?
To the current code for that?
Yeah. For your basketball checker? I know you have a donate button there.
Yeah, let me should be okay. So go to where the donate button is.
Yeah.
So so this is literally just a Stripe link.
Yep. Okay, cool. So here's what we're going to do, right? Is that we're just going to add the if window.webln above that, right? And so now they're just going to hit the button. And if there's WebLN in the browser, well, then that person can donate to you in Bitcoin, right? And so it'll ask for the donation in Bitcoin. Or if they don't support WebLN, then it'll go to Stripe, right?
Okay, so we need to.
You need to get the
enable stuff.
Yeah. So you can just copy that stuff from over there, like get invoice. I think you moved it into the
yeah. So we could just add this as a function here. We can just add that up here.
Yep.
And then we'll just do invoice equals weight. So you know what? That's a React thing. Let's do it up here.
Yep. Yep, there you go.
Cool. Looks good. Oops, red equals. There we go.
Yep. So you get the invoice, and you do. So once you have the invoice, then you do const pre-image.
That's just
sorry. So this is inside of window.webln, right? So if WebLN is there, then you go through the WebLN flow, right? But if it's not, then you go through the Stripe flow.
Okay. So I see. Else. Okay.
Else window.open that one. Right.
And let's see.
With that one. And then afterwards send like an alert or something. If not pre-image, then not pre-image, then alert. Thanks for the sats. There you go. Cool. And then I would do not send the else, not in an else. I would just have that be yeah, you could do the same window.open or whatever, right? So it's like if they don't pay you over Lightning, then they just go to the Stripe link anyway, right? But if they do pay you over Lightning, then it doesn't go to the Stripe.
Okay. I see what you mean here.
Right? So that's like not the cleanest way to do it, right? But
right.
And so when you go to localhost,
should
shortcut listen. What is that?
Oh, you know what it is? It's I get away. We're gonna cheat a little bit. Provider must be enabled. Oh,
you gotta wait.
Enable. Yeah.
Yep.
That's
wait, window.webl.enable.
Yes.
Yeah. Or you can just do await window.wait webl.enable. You don't have to do it in the promise syntax like that.
And again, it was TypeScript errors.
It's yeah.
Be able to await that.
And then you need the TypeScript error handling thing that you did above too. There you go. Sweet.
It should be good. Boom.
Nice.
Check that out.
Isn't that cool? So that's like the
Very
whole
cool.
process for adding Lightning payments in, right? And if you get a Lightning payment for that one, then then you immediately get stats. What is that? User rejected. Yeah, so it was an error.
Yeah.
There you go. Thanks for stats. Cool.
Very cool.
And so that was the whole process of adding to like your existing application, just adding a WebLN donate button flow, right? And when you get paid in sats, then you just get sats immediately, and there's no chargeback, there's no waits. Like there's no minimum payment amount for the donation or whatever. They can send you like a couple millisats, right?
Yeah. And for people watching, the idea is you tokenize the input that you'd be sending and just calculate that cost as sats.
Yeah.
And then you have, maybe put a little bit of a buffer on it. You put a 10% buffer on it just to be safe.
Yeah.
And then boom, you can pay for your API calls without having to make users bring their keys.
Exactly.
Lightning, which is very cool.
I think that would be a good follow-on for this one of that. We do the macaroons and then we actually do the tokenization aspect for it, right? So instead of just doing the pass, we like separate out the token call, right? And so we do that in the initial payment.
Because we did sort of the janky hard-coded version of that, which is great for proof of concept, but that's not how you're going to want to do it in production.
Yeah.
But yeah, I see what you mean here. That's very cool.
Cool.
And then just like that, we put it right in something I put out last week that would be able to
notice like that part. Like we did like the whole long process of doing the server-side authentication, all that kind of stuff, right? But like the actual process of adding the Bitcoin donation button to that was like seconds.
Right.
And
so like for my problem was people, so like this Stripe link defaults to like a $2 donation. So it's like a few people did that, but it's like if you're someone who just uses it once and you use literally like half a cent of tokens, then you just pay half a cent of tokens, which is super nice. Yeah. So it's nice from the perspective of the person who has their product hosted, because then they get paid appropriately and they don't have to think about costs. It's really nice from the user's perspective because you only pay for what you use as opposed to having to overpay, which is very cool.
Yeah. And the great part about it too, right, is that this is just something for you as a developer. Like, I don't think you want to handle people's personal information, their credit card information, right?
Right,
Like,
right.
you would prefer to just receive money as they use your service. And if you want to be philanthropic about it, then they just pay you exactly what it costs. Otherwise, you make a little bit of money. Sorry, that's my dog with a tennis ball. But
I love it.
the
Dog's here to party. Dogs
but
lightning.
so we can do a couple other things, right? I mean, like for follow-on stuff, we can do macaroons, we can do login with Lightning, where you can have a persistent user identity for the user, but they're just a public key, right? So there's nothing associated with them, and there's nothing to correlate them across different websites. Like with Alby, you just log in from Alby and you become a public key, right? Like you could actually do this right now if you just go to stacker.news, right? That has like a good login with Lightning. And then you just do login with Lightning. There, copy, paste that into Alby. Send.
Send. Oh, that's cool.
There you go.
Very cool.
So
Check that out.
And now if you go look at your identity up top, right, you have a persistent identity on the website now on the top right, but you're just a public key. So your profile. So that's something where Stacker News can do that to attach encrypted persistent storage and stuff to you. They can send you that encrypted stuff back and know that you can decrypt it on your side, right? So they don't have to store any of your information, right? You're just a public key and a bunch of encrypted files. And I'm just serving those back to you and you're decrypting them client side, for example, right? And I'm comfortable doing that because you can pay for me for everything that you do for there, right? Because I know you're a Lightning wallet. I know you can pay for the service that I'm offering you, right?
Yeah.
Yeah. So it's very cool. Yeah. So I don't know. Hope you
very slick implementation. Yeah. I am quite impressed obviously you have to walk me through how to do it the first time, but if I wanted to do this again, it would be very quick.
And we could use NPM packages and stuff. This was like a full implementation of the entire handshake on both sides, right? But it's like I showed you with the bolt wall, right? Where it's just app.use bolt wall, and then like you don't change anything else but your Express app, right?
Yeah. Cool. Very cool. Do you want to let people know what else you've got going on this month with
AI sure. So stuff? We've got the AI for All hackathon. I should have plugged it at the beginning, right? Like McKay's
I know. I'm just remember. I'm like, we should probably plug that really quick to make sure.
McKay's going to be a judge for it as well, and so there's a $10,000 grand prize. There's a bunch of prizes associated. We're going to be putting some Replit bounties out for kind of like little snacks as you move along through the hackathon, and we've got workshops all through next week and the week after. We did a bunch of them this last week, right? Of just like how to wrap AI stuff with Lightning payments, right? And so. It's pretty cool. So like tomorrow, for example, we've got Nifty Nye, who's like one of the like core Lightning developers. She's going to be doing one on how to wrap Flask endpoints with bolt walls, kind of, right? And so it's cool.
Bolt.fun is the best place to get all this info. Yeah.
Yeah. AI for all on there.
Bolt.fun
is the name of the hackathon.
And then AI for all. Let me drop that link over here. We'll see that.
Cool.
Very cool. And that hackathon is on August 3rd, correct?
The judging is on August 3rd. So the final.
Okay, so the projects are all throughout the month. Okay.
Yep. So just as you're going along, and like it's okay, you could like cross post for this for other things or whatever, right? Like we just want to see cool AI and Bitcoin applications, right? It's like this is just like one of those. Like McKay is like a perfect example of this. It was like an AI creator in search of a monetization strategy that doesn't involve like bring your own API key. Yeah. Right.
So if you wanted to implement what we just did in something, that would be very cool. Or if you wanted to take it even further and to do something with agents, that would be. There are a lot of very cool projects that you can do. So this is a super cool thing.
Yeah, we're gonna have some workshops on agents next week. So that'll be fun. And I think if we do a follow up, it would be cool because some of the takeoff school stuff that you did, like I've been wrapping those with Lightning payments. Yeah. And so that would be good stuff.
Yeah, and we'll get the VOD downloaded for this too, so that people can watch this later. I imagine a lot of people couldn't make it live would want to check out what we did here, which would be really cool.
Totally. All right, this is great, man.
All right, Cody, that was awesome. That was I feel like I have a lot of research I need to do to better understand the protocol level stuff.
Always here for
very cool to see the code in action working. Especially bringing that into a project that I've already done, which is cool.
Yeah.
So thank you. That was very, very fun.
Thank you, dude. Yeah, you were one
Yeah.
of like inspirations for me as I was getting into coding, right? Because like you were
Yeah, I
fresh
appreciate
out of
that.
Lambda school and just like starting building in public.
Yeah. So if you need motivation to learn a code, you can do cool stuff like this. Don't let anyone tell you that it's not a good time. AI is not going to get rid of developers. Developers are going to be even more important. So go learn how to code, and you can do cool stuff like Cody does here with AI and Lightning.
All right. Thanks, Kay.
Yeah. See you, Cody. I'll talk to you.